Hi guys, here is an interesting number theory problem. Let's read the problem. Find the remainder of 257 to the power of 33 plus 46 whole power 26 when it is divided by 50. So as you see, 257 is congruent to 7 mod 50. So that means 257 to the power of 33 is congruent to 7 to the power of 33 mod 50. So 7 square is equal to 49 and this is already congruent to minus 1 mod 50. So this implies that 7 to the power of 32 is congruent to minus 1 whole to the power of 16 mod 50. This implies 7 to the power of 32 is congruent to 1 mod 50. This implies that is 7 power 33 is congruent to 1 mod 50, is congruent to 7 mod 50. Now let us find out. Now 46, as you know, is congruent to minus 4 mod 50. We simply add these remainders, minus 4 and 7. So this gives us 3. So we just left out to finding 3 power 26 is congruent to dash mod 50. This implies that 3 power. Now we take the Euler's Totient function. First let me explain to you what the Euler's Totient function is. As you know, Euler's Totient function, it is basically let's consider a number. Let us consider a number x. Then it is basically the number of numbers that are relatively prime to it. For example, let me take x. The 3 power some function is congruent to dash mod 5. So we here are is congruent to 1 mod 5. This is base. So that means 3 to the power, it is actually denoted by the function phi of the number x. So what this will do is when you take congruence, so phi of that 3 to the power phi of that number, phi of 5, that is congruent to 1 mod 5. So that means phi of 5 is what? It will be 4. Since 5 is a prime, the phi of any prime number p is equal to p minus 1. So it's simple. Phi of p is p minus 1. So what we do is the general form of phi of any number, that will be n times 1 minus 1 by p1 into 1 minus 1 by p2 and so on, where p1, p2 and p3 are all the prime factors of n. So all of these are prime factors of n. So, but phi of any prime will be p minus 1. That is, these are just the number of numbers that are relatively prime to it. Number of numbers relatively prime to it. So I'm not going to show this. So I close this off. So now let's go back to our. So 3 to the power of 4 will always be congruent to 1 mod 5. That's all obviously 81. That is congruent to 1 mod 5. Since this is 80 plus 1. 81 is equal to 80 plus 1. So now we go back to the problem. So now they were asking 3 to the power of 26 is congruent to dash mod 50. Remember, the Euler's Totient function only works if the GCD of the 3 and 50 are 1. That is GCD of that number and the divisor are 1 only, basically. So we observe that GCD of 3 and 50 is 1. So in that case, what we do is we take phi of 50. This is equal to 50 times 1 minus 1 by 2 into 1 minus 1 by 5. This will be equal to 50 into 4 by 5 into 1 by 2. This is equal to 50 times 4 by 20. 4 by 10, I mean. 10 ones are 10 fives are. So we get 20. So that means 3 to the power of 20 is congruent to 1 mod 50. So 3 power, we just have 3 power 6 left, that is 729. So this will be congruent to 29 mod 50. That's all. So it implies that 3 power 26 is congruent to 1 mod 50. I hope guys you enjoyed this video and see you in the next video.